Okay, so today's class we are just going to review sine, cosine, and tangent. Our first question on this sheet, again this is in your modules, we are looking to find the value of each trigonometric ratio. Express your answer as a fraction in lowest terms. So I've just put our acronym here, so SOHCAHTOA right there on the corner. So sine of C. So let's take a look here. Here is C, that's our angle C. So pertaining to that, because it says sine C, we're going to look at our opposite and our hypotenuse to make our ratio. All right, so we're going to call this sine of C is equal to opposite, which is 21, and hypotenuse, or hypotenuse is this one here, which is 29. So we're going to leave that as sine C equals 21 over 29. It does say express your answer as a fraction in lowest terms. This cannot be reduced any further, so our answer is just 21 over 29. All right, so let's say we had to find sine of A. Okay, our angle A is here. All right, so angle A is there. Let's find sine of A. Sine of A, opposite is 20, and hypotenuse is still 29. So sine of A is 20 over 29. All right, so our next example, let's try number 4, and it's asking us to find the cosine of C. So cosine of C, there's our angle C. So cosine of C, we know from our acronym that we have to have adjacent over hypotenuse, right? So adjacent over hypotenuse. So go to your angle C. Which side is adjacent? Adjacent is 8. Hypotenuse is 17. So 8 over 17 is our ratio. And again, we cannot reduce this any further, so we're just going to leave it as cosine C equals 8 over 17. All right, again, it's because this question has specifically asked for our answer to be in a fraction in lowest terms. It hasn't asked us to put it into decimal form. Okay, let's try another one here. Let's try tan of A. Let's do this one. Let's do number 5. All right, so there's our angle A, there's B, and there's C. So tan of A, using SOHCAHTOA, tan is opposite over adjacent. That's the TOA. So tan of A is equal to opposite, which is 12, and the adjacent is 35. Okay, so we're going to leave it at 12 over 35. And hypotenuse here was 37, but our tan ratio does not use the hypotenuse. So we just needed to know our opposite and adjacent, and this cannot be reduced, so we're going to leave it as 12 over 35. Okay, so here we're looking for tan of x. I'm going to write the SOHCAHTOA here again. All right, so our tan of x, our x is here, and we're looking at opposite over adjacent. So tan of x is opposite, which is 36. Adjacent is 27. All right, remember you're not using the 45 because that's the hypotenuse. All right, the tangent ratio is only looking at opposite and adjacent. So once you've put this into the fraction form, it does say to put it into lowest terms. So I can use 9 to reduce, so I get 4 over 3. All right, so tan of x is equal to 4 over 3. Our next question, our next set of questions say to find the value of each trigonometric ratio to the nearest 10,000th. So in this case, you can either use the chart that's provided, the trig ratio chart, and you just have to go to the sine column to 62 degrees and figure out the ratio. to decimal form, but you can also just use your calculator. So in your calculator, I'm just going to put this here, you're just going to type in sine of, the first example is 62, close your bracket, and you get your answer. All right, so they want it to the nearest 10,000. So we have our tens, hundreds, thousandths, 10,000ths. So 0.8829 would be our answer for that one. Okay, so 0.8829 is the answer for that one. All right, so those ones are very simple. You're just typing it in your calculator or just using your trig ratio chart. All right, next we're trying cosine of 60 degrees. So question number 9. So here is my calculator. I'm just typing in cosine of 60 degrees, and it's just 0.5. All right, so since they want it in nearest 10,000th, you can just put here 0.5000 or 0.500. I put an extra. No, 1, 2, 3, 4. No, that's right. All right, and the last one, let's try a tan of 79. So again, I'm just going to use my calculator. I'm just going to type in tan 79, and that gives me 5.144, and then we'll round the 5 up to 6. So 5.1446. Okay, next section here on page 2 is find the missing side, round to the nearest tenth. So we have to figure out which ratio to use to figure out our missing side. Again, we cannot use the Pythagorean theorem in these questions because we are only given one side. To use the Pythagorean theorem, you need to know 2 sides to figure out the third side. All right, so therefore we have to use trig. So I'm just going to put our ratios here. So our SOHCAHTOA up here. All right, so SOHCAHTOA, let's take a look. We are given this angle of 59 degrees. So using 59 degrees, we have to figure out side x. That's the one that we have to figure out. All right, so using our angle of 59 degrees, x is opposite, and what we're given is our hypotenuse. All right, you can always find your hypotenuse. It's right across from the right angle. So in this case, because we're using opposite and hypotenuse is our sine ratio. So you're going to set it up as sine of 59 is equal to opposite, which is x, over 17. Okay, so here in this case, we just have to use cross multiplication, or you can use algebra to solve for x now. And so we're just going to type into our calculator sine 59, and then you're going to multiply by 17. Sine of 59, and then multiply by 17. All right. So if you're looking at my calculator here, I've typed it in like this, and I get my ratio, or I get my missing side, of 14.57. The answer needs to be put into the nearest tenth, so I'm going to round it to 14.6. So that means our side x is equal to 14.6, and there's no units, so we'll just leave it as 14.6. All right, so we're trying question number 18 next. The missing side we're told to solve for is x, which is right here. The angle we're given is 53 degrees, which is right here. All right, our hypotenuse is the side right across from the right angle. So this side here is our hypotenuse, which we aren't given. So we can use opposite and adjacent, which is our tan ratio. So tan of 53 is equal to opposite, which is x, and adjacent, which is 12. To solve for x then, we're going to multiply tan of 53 multiplied by 12. So in my calculator, I'm just going to type that in. Tan 53 times 12. Make sure to close your bracket when you put it into your calculator. Okay, so just to show you what it looks like in the calculator, I've put it in like that, and rounded to the nearest tenth, my answer would be 15.9. So x is equal to 15.9. Again, there's no units given, so I would just leave it like that. So question number 17, we are looking for this side here. This is the side x we're looking for. This side here is the hypotenuse. So looking at the angle that's given, we're given angle 40 degrees. All right, so the ratio we can use here to figure out x would have to be opposite and adjacent. All right, because this one here is the hypotenuse. So opposite over adjacent, that's our tan ratio. So we would write this out as tan of 40 equals 20 over x. All right, so in this case, our x that we're trying to solve, it's on the bottom here. So when we're solving for this, I always use cross multiplication. So I always assume this is over 1. So I do 1 times 20 divided by tan of 40. So it's 20 divided by tan 40 when you're solving for x. All right, when we looked at this previous one, the x was on top, so we just had to multiply the 2. Because the x is on the bottom in this case, it becomes a 20 divided by tan of 40. All right, so put that into your calculator. 20 divided by tan of 40, which gives me an answer of 23.8. Yes, thank you. All right, 23.8 is the answer. And again, there's no units given, so we will leave it as 23.8. All right, so next question. Find the measure of the indicated angle to the nearest degree. So we're just rounding them to the nearest whole degree and no decimals. So the first angle we're looking for is this one. That's our missing angle. All right, so using the two pieces of information that we have here, we have our opposite, and this one here is our hypotenuse. Okay, so again, this is the missing angle. Right across from it, this is opposite, and this is the hypotenuse, all right? Because the hypotenuse is always right across from the right angle. So hypotenuse is 44, and opposite is 39. All right, so because we have opposite and we have hypotenuse, we're going to use our sine ratio. Okay, so again, I'm just going to write that out here. Okay, so setting this up, I'm just going to call that missing angle x. So sine x is equal to opposite, which is 39, over hypotenuse, which is 44. So because we're solving for an angle, this is where you have to use second function sign in your calculator. You can still use the chart. That's okay as well. All right, so typing this into my calculator, I am going to type in second function sine, like so, and then it's 39 divided by 44. Close the bracket, and we get an answer of 62.4. So our degrees rounded to the nearest degree is 62 degrees. So our missing angle x here is 62 degrees. All right, so question number 22, this is our missing angle here. Okay, that's the angle we're trying to solve for. And the pieces of information we're given, we are given our hypotenuse, which is here, and we are given adjacent, which is here. All right, the side we are not given is opposite, which is here. So using what we're given, which is hypotenuse and adjacent, we can use our cosine ratio, adjacent and hypotenuse. So we're going to use cosine. So we're going to set this up. I'm going to again call the angle just x. So cosine x is equal to adjacent over hypotenuse. Adjacent is 20 and hypotenuse is 23. All right, and because we are solving for an angle, when you type this into your calculator, you're going to use second function cosine. Okay, so we're just going to put it right here. So second function cosine is 20 divided by 23. So 20 divided by 23, close your bracket, and we get 29.59. We have to round that. We're going to round up, and we get 30 degrees. All right, so for question 23 is the one we're doing next. And so we have a missing angle here, and we have our opposite and our adjacent. This line here is our hypotenuse, which we don't have. So using our opposite and adjacent, we have to use our tan ratio. So setting this up is tan x is equal to opposite is 10, and adjacent is 33. So tan of x is equal to 10 over 33. When you type this into the calculator, you're going to put in second function tan. Second function of tan is 10 divided by 33. Close the bracket. And we get 16.858. So we got to round this up to 17 degrees. So x is equal to 17 degrees. All right, so we'll just do one word problem. This is number 32. We'll do from a horizontal distance of 80 meters, the angle of elevation to the top of a flagpole is 18 degrees. Calculate the height of the flagpole to the nearest tenth of a meter. So let's say that's our flag. There's our flagpole from a horizontal distance of 80 meters. Okay, so here's our horizontal distance. It's 80 meters. The angle of elevation to the top of a flagpole is 18 degrees. Angle of elevation is always taken from the horizontal elevation. You would go upwards. So this is 18 degrees right there. And we have to calculate the height of the flagpole. So we'll call this x. That's what we're trying to find. All right, so we're trying to find a side. We're given our one angle and we're given a side. So looking at our angle of 18 degrees, and sorry, this is where our right angle is made. So we need to figure out opposite. That's what we need to figure out. And we are given adjacent. Okay, we don't have our hypotenuse here. So from angle 18, we have opposite to figure out, and we're given adjacent. So we have to use our tan ratio. So tan of 18 is equal to opposite, which is x. Adjacent is 80. All right, and then you're just going to multiply that out. Just x will be equal to tan of 18 multiplied by 80. All right, since we're looking for a side, you're just typing in as tan of 18 times 80. Just like this, I've just typed it in here. Tan of 18 times 80, and we get 25.99 to the nearest tenth of a meter. So it's going to have to round up to 26.0. So x is equal to 26.0, and it's in meters. So that means the height of the flagpole is 26.0 meters.